Hello everyone. So today we're going to have the hypothesis testing for a single sample, and for this presentation we will be having the test on the mean of a normal distribution with variance known. So if the variance is known and we want to test mean, we're going to have the null hypothesis to be mu equal to a known value of mu. So the null hypothesis is HO, mu is equal to a certain value. So say for example 5. The alternative hypothesis would be it is either not equal to 5, greater than 5, or less than 5. The formula for the p-value is 2 times 1 minus the p-value of the absolute value of z. So take note, we take the absolute value of z. So twice of 1 minus phi of the absolute value of z. For the greater than, it would be 1 minus phi of z, and for less than, it would be phi of z. So that is aligned with the rejection regions. So if the alternative hypothesis is not equal, the critical region is to the left and to the right. So that's z less than negative z and greater than 0. So if it is greater than 1 minus phi of z, and if it is less than, it would be to the left. So the distribution of z when the null hypothesis mu is equal to mu sub o is true with the critical region for the two-sided, one-sided alternative, and one-sided alternative. So not equal, so that is a two-tailed test. For greater than, it is a right-tailed test, and less than, left-tailed test. The life in hours of a battery is known to be approximately normally distributed with a standard deviation sigma equals 1.25. A random sample of n is equal to 20 has a mean x bar 40.5. So this is given in the problem. So the variance is known. For the question, is there an evidence to support the claim that the battery life exceeds 40? So the average life is 40. So we're looking for to check the claim that it is greater than 40. So claim the average is greater than 40. It is exceeding 40. What's the p-value for this test? So for the computation, we're going to use z is equal to x minus mu. Wait. We're going to use the formula z is equal to x bar minus mu over sigma divided by square root of n. But we can use our Excel solver. So we are given with n, sigma, and x bar. So we place here your n, your x bar, and your sigma, 1.25. And we test that it is equal to 40. So is there an evidence to support the claim that the battery life exceeds 40 hours? So first, let's identify the null hypothesis and the alternative hypothesis. This is the claim. So we place this claim under the alternative hypothesis. So the null hypothesis is equal to 40. So we use the third one. Sorry. This is less than or the null hypothesis would be less than or equal to 40. The alternative is greater than. So this would be the case that we are considering. So the null hypothesis is less than or equal to 40. The rejection region is to the right because it is greater than. The test statistic would be z equal to 1.79, and if we will be using 5%, the critical value is 1.645. So it is located here on the rejection region. So since the computed value is 1.789, which is much greater than 1.645, so the decision is to reject the hypothesis. We reject HO, so mu is indeed greater than 40. And we can see that the p-value is 0.0368, which is less than 0.05. So the probability that we would be committing type 1 error is less than 5%. So we might forgo it since it is less than 0.05. Since the probability of committing type 1 error is 3.68%, so we reject the null hypothesis. We accept the alternative that mu is greater than 40. Another problem. The mean water temperature from a power plant cooling tower discharge should be no more than 100 degree Fahrenheit. No more than 100 is less than or equal to 100. Past experience has indicated that the standard deviation is 2. The water temperature is measured on 9 random days, and the average temperature was found to be X bar 98. Is there an evidence that the water temperature is acceptable at alpha is 0.05? So the null hypothesis is acceptable. When is it acceptable? When the mean is less than or equal to 100. The alternative is the mean is not acceptable, so greater than 100. So greater than 100. So to the right. If the alpha is 0.05, so it would be 1.645 located to the right. The z value, the z computed is -3. So it is here, -3. This is the failed to reject region, and this is the rejection region. So obviously, we failed to reject the null hypothesis. So the null hypothesis is less than or equal. So the p-value is 0.9987, which is greater than 0.05. So if it is greater than alpha, we fail to reject the null hypothesis. If it is less than alpha, we reject the hypothesis. So for this case, fail to reject the null hypothesis, so mu is less than or equal to 100. So the p-value is 0.9987. For a large sample test, when n is greater than or equal to 40, we assume that sigma is equal to S. So we can still use the procedure for known variance even if the variance is unknown. The average farm size in the United States is 444 acres. So the average 444. There is a sample of 40 which yields 430 and a standard deviation 52. At alpha is 0.05, can it be concluded that the average farm in Oregon differs from the national mean? Use the p-value. So we plug in x bar 430, n is 40, sigma is 52, and mu is 444. So the null hypothesis is, can it be concluded that the average farm differs? So not equal to 444. It is different from 444. So the null hypothesis is it is equal to 444. So we have a two-tailed test. We have 5% error or 0.05. So 2.5 on both tails. So we have negative 1.96 and positive 1.96 on either tails. The computed test statistic is negative 1.70. So it is on the acceptance region or fail to reject region. So do not reject HO. So if we're not going to reject HO, so mean is equal to 444. So we're going to use the null hypothesis of equal against the alternative not equal. The p-value is 0.09, which is greater than alpha. So since it is greater than alpha, we do not reject the null hypothesis. These are the references for this lesson.